Hello, grade 8. This is Mrs. Lopez, and today we are working on lesson 2 in our module 1, multiplication of numbers in exponential notation. So, first things first, let's just remind ourselves what exponents are. Exponents are really is repeated multiplication when the base number is multiplied by itself as many times as the exponent shows, right? So today we are learning how to multiply these numbers that are written in exponential notation. Let's take a look at our first example. So let's say I have to multiply 3 to the 5th power by 3 to the 7th power. So 3 to the 5th power I can rewrite as 3 times 3 times 3 times 3 times 3. And that is repeated 5 times. I can rewrite 7 as 3 to the 7th. 3 times 3 times 3 times 3 times 3 times 3 times 3. 7 times. Okay, so now if I'm look at it, I will see that I have all of my 3's are multiplied together, right? By themselves. There is no other numbers. It's just 3 multiplied by itself. How many 3's do I have? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. I get 3 multiplied by itself 12 times. So 3 to the 12. What happened is I really added, right? 5 and 7. So 3 to the 12th is 5 plus 7. Okay, I just added the exponents. Let's take a look at the second. Let's say I have 5 to the second times 5 to the fourth. Okay, so let's see if that works on here as well. I have 5 times 5, 2 times, and I have times 5 times 5 times 5 times 5, and that is 4 times. I'm taking the same number and multiplying by itself 1, 2, 3, 4, 5, 6 times, right? So that really is 5 to the power of 2 plus 4, which is 5 to the 6th power, isn't it? Let's see if that works with all the numbers. Let's take a fraction. Negative 2/3 to the 4th power times negative 2/3 to the 5th power. Okay, so here I have negative 2/3 multiplied by itself 4 times. 2/3 negative 2/3. Okay, and then I'm multiplying by itself, again, negative 2/3, 5 times. Okay, so you got the point. It looks like it does work the same way, right? I have negative 2/3 to the power of 4 plus 5, which is going to be, right here, negative 2/3 to the power of 9. Now remember, we always have to have parentheses around negative 2/3. Otherwise, the 9 will be only on top of the positive 2. And that is not what we are looking at right here. We are looking at the actual whole fraction of negative 2/3, okay, to the 9th power. All right, so I think we got the point here, right? So if I'm taking the same number with the same base, right, the bases are the same, and multiplying it by itself, um, I will just need to add the exponents, right? So when I'm multiplying 3 to the 5th by 3 to the 7th, I'm really multiplying 3 by itself 12 times, okay? So here's a rule that comes out of this. If I'm taking a number that has the same base, so any x to the mth power, and I'm multiplying it by the same base x, let's say to the nth power, my product is going to be x to the power of m plus n. I'm adding the powers up. Right, so here's time to try some exercises. I need you to do exercises 1 through 20. 1 through 20. And once you're done, come back and we will check the answers. All right, so here are the answers. Um, so for number 1, you have the same number 14, the same base multiplied by itself 23 times and multiplied by itself 8 times. So basically what you're doing is you're adding the exponents, 23 plus 8, and that is 14 to the 31st power. Exercise 2, make sure you have parentheses around negative 72 because that's what you're going to multiply by itself. And negative 72 to the power of 10 multiplied by negative 72 to the power of 13. You're adding the exponents, and that is negative 72, to the power of 23. Next one, number 3, 5 to the power of 94 plus 78 is 5 to the power of 172. Exercise 4, negative 3 to the power of 9 times negative 3 to the power of 5. You're adding exponents, and you get negative 3 to the power of 14. Number 5, same exact thing, but our base is a variable. A to the power of 23 plus 8 is a to the 31st power. Again, notice it only works when we have the same base. Next one, f to the 10th times f to the 13th is f to the 23rd. B to the 94th times b to the 78th is b to 172nd. And last one, if x is a positive integer, then negative 3 to the 9th times negative 3 to the x is negative 3 to the 14th. So since I have to add 9 plus x to make 14, I know that x is 5 because 14 minus 9 is 5, right? Okay, next one. Number 9. Here you have 9 to the 4th times 9 to the 6th times 9 to the 13th. So you're adding all the exponents and you get 9 to the 23rd. Same thing for exercise 10. You're adding all the exponents and you get 2 to the 24th. For number 11 is different because not all the bases are the same. We have 6 to the 5th, and we have 4 to the 9th, and 4 to the 3rd, and 6 to the 14th. So what I did, I first used commutative property of multiplication to show you that I'm going to work with the 6 first, and then with the 4, and then I added the exponents, which is 5 plus 14 is 19, 6 to the 19th. And now we are working with the 4th. 4 to the 9th times 4 to the 3rd is 4 to the 12th. I cannot multiply any further because these are not the same base. Okay? Same works for exercise 12. We have negative 4 to the 2nd times 17 to the 5th times negative 4 to the 3rd times 17 to the 7th. You're only adding exponents on the same base. So negative 4, we are adding 2 plus 3, and 17, 5 plus 7. That ends up in negative 4 to the 5th times 17 to the 12th. Number 13, exact same thing, except for you need to remember that 15 is used once, is 15 to the first power. So that means you will have 15 to the 3rd because we are adding 2 and 1 more, and 7 to the 6th. So 15 to the 3rd times 7 to the 6th. Again, this is not plus anymore, just like we did before, but this is repeated multiplication, so this is all multiplication. Number 14 is slightly different from before. If you remember that 8 is 2 to the 3rd power, 2 to the 3rd power, and I got that because I know that 8 I can make a prime factorization tree, right? So if 4 times 2 and 4 is 2 times 2, so you know that 8 is 2 to the third power, and that is to the second power. It means 2 to the third, I'm multiplying by 2 to the third, and I will get 2 to the sixth because 3 plus 3 is 6, right? So that's where they got that 2 to the sixth from. 2 to the fourth times 2 to the sixth is 2 to the 10th. Same for number 15. They changed 9 into 3 to the second. And so 3 to the seventh times 3 to the second is 3 to the ninth. Okay. Exercise 16, there is nothing we can do. 5 to the fourth times 2 to the 11th, different bases. I cannot do anything with it, and I cannot simplify either 5 or 2 to have a base that is the same. Okay, so I'm just rewriting as it is without changing anything. Okay, number 17, let x be a number, and this is all multiplication, right? 2 times x to the third is 2 times x to the third. Parentheses without a sign means it's also multiplication, right? So times 17 times x to the seventh. So what really is this is all multiplication, and I just expanded it. 2 times x to the third times 17 times x to the seventh. And from here, I see that I can multiply 2 by 17 and get 34. And I can multiply x to the third by x to the seventh, and I will be able to combine the exponents, and I will get 34x to the 10th. Exercise 18, I'm going to use the distributive property to multiply a by a. A times a is a to the second power. A times b is ab. Okay, so a times a is not 2a, is a to the second because it's repeated multiplication. Same goes for the next one. When we have exercise 19, we have b to the second because I'm multiplying b by itself and ba next to it. You can call it ab, you can call it ba. Still the same thing, right? Exercise 20 is a little bit tricky. That's why I put a star next to it. Basically, what you want to do is you want to multiply a by both a plus b. So that's a distributive property that we are using. And then we'll have to multiply b by both b and a. And that will give us, from the previous problem, we had a squared plus ab. And from the 19, we have b squared plus ab, right? So you combine like terms, ab and ab, you end up with 2ab plus a squared plus b squared. Okay, you can also write it in, if I were to draw it for you and made an area model. So this is a plus b, and this is a plus b, right? A times a is a squared, a times b is ab, b times a is ab or ba. Its commutative property doesn't change if I switch the numbers around, and b times b is b squared. And that's how we get a squared plus 2ab plus b squared. Okay? All right, so this is all for numbers 1 through 20. And in the next lesson, we are going to learn how to um, divide numbers in exponential form. Okay? So if you don't have any questions, I will see you in the next one.